Sorry for the interruption. We left off at the integration of, oops, this. So the integration of the velocity to obtain position. So here we defined velocity as this equation. So if you do this by parts, this integration here is s minus s0, which is what we have here. And my screen has frozen. Okay. So, and then here, you need to review your calculus, and I'm going to upload a sheet for calculus. So this is what we have. Let me do this. So B0 plus ACT BT. It doesn't look very good, but anyway, so B0, then we have a constant B0, so the integration of this would be B0T, and then ACT, so AC stays outside because it's a constant, and then you have 1/2 T squared minus 0. So this is what we have here. And doing the same procedure here with the acceleration and the velocity. Once again, we have the equation here, and I'm not going to go through everything, but you should be able to do this. Anyway, for this part of your education here in Civil Engineering Fundamentals, I just want to introduce these concepts to you, that the derivative of the position gives you velocity, the derivative of velocity gives you the acceleration, and then if you go backwards, the integration of the acceleration gives you velocity, and the integration of the velocity gives you position. Okay, so that's the principle you have to remember, but what I want you to really think about is more in terms of the concept itself, that you have a distance and you have an average velocity based on that distance, an instant velocity that then uses the derivative, and when we look for average acceleration, then you look at the difference in velocities with this difference in time, and if you're looking at the instantaneous, then you look at the derivative. So I hope that makes sense. So based on that, if we have this example of particle traveling in a straight line, and this is the velocity, and you have at s equals 0, t is 0, what is the velocity, the position and acceleration of the particle when time equals 4 seconds? Well, if you have time equal 4 seconds, you can obtain directly here substituting the velocity. So the question is, how do you obtain the acceleration? Well, the acceleration, you have to do the derivative of the velocity, right? So we have here the derivative of the velocity to obtain the acceleration. And again, I'm going to give you a cheat sheet. So the derivative of 4t is 4. The derivative of 3/2 squared would be 3 times 2 times t, which is 60. So there you have the acceleration. Okay. For the distance traveled, then you have the derivative of the position is the velocity, but remember here, let me see what is the original. So we have this is the velocity, so remember that the derivative of the velocity gives you position, and the derivative of the acceleration gives you velocity, but then the integration of the velocity gives you position. to obtain then the position. Okay? I hope it's making sense. If not, we'll review again. Okay, so we take the derivative of the velocity to determine the acceleration. Okay, so here's your derivative, and then the distance traveled. You have to have the, you can rearrange the expression or say, okay, the velocity is the derivative of the position. So whenever you integrate that velocity, you get the position. Okay, so here you had the velocity expression, and then you integrate over time to get the equation for position, and then just substitute the time. So this is another concept quiz, and the exam will be along the lines of these concept quizzes. So make sure you understand these concept quizzes, pause the video, read it, and here you have both questions, and these are the answers for each. Okay. Here I presented the attention quiz, so look at these questions, read them, understand them. If you don't have any questions, please give me, send me an email. Okay. So do the group problem solving that is in Blackboard, and the solution is presented as well in Blackboard. I hope you're ready to do the problems. Thank you for your attention.